right, we have our warm-up for today. Yesterday we did add, subtract, and multiplying, so the next few days we're going to focus on division of polynomials. So with what we're doing today for our warm-up is we're going to use long division for this question, then we're going to use synthetic division for this one. We'll talk a little bit more about when you can and cannot use synthetic division when we get to this question right here. But first, with long division, we treat it like we did when we were doing long division with just regular numbers, when you have a small number going into a huge number. So we treat it the same exact way here. We have to set it up appropriately. We're going to take the n minus 7 and set it up over here. Put your divided by sign. Look for any breaks, meaning does the degree change? You have a second degree, first degree, and a 0 degree, so it's already in order. We have 2n squared minus 16n plus 19. So from here, we have to figure out how we're supposed to get this term right here to match up with that term. So you have to use multiplication here. N times what gets me 2n squared, so I need a 2. N becomes n squared by multiplying it by n. So what you do to one part, you have to do to the whole thing, n minus 7. So I'm going to use distributive property, and this is going to go right here. So 2n times n is 2n squared. 2n times negative 7 is negative 14n. Okay? You stop right there. We have it matched up. We see that these two are the same. Now we have to add a line, change the signs, cross out, and combine right here. Negative 16 plus 14, negative 2n. And what you do here is you go ahead and bring down the 19. Right here, what did I multiply by? 2n. It's going to go right up here as part of my final answer. So now we have to match up this negative 2n. Well, how do I get n to become negative 2n? I multiply by negative 2. So negative 2 times n minus 7, use distributive property, gives me negative 2n, and that's going to be plus 14. So from there, we're going to go ahead and do our rhyme again. Add a line. Change the signs, cross out, and we go ahead and combine. When we do our combination right here, this is going to give us 5. This is a remainder because there's no way for n to be multiplied by something to get me 5 unless we multiply by something over n, which we're not going to do that. So right here I've got 2n minus 2, and I have a remainder of 5. That is an answer, but the way that I would like these answers to be written is in remainder theorem form. So you're going to write it like this. 2n minus 2, and you have a plus sign and a divisor. You've got 5, and then on the bottom you put what you divided by, n minus 7. That takes care of long division for this question. The next one we're going to use is synthetic division. Synthetic division only works if you have a 1x or a 1y, and then you just have a number in the back, some positive or negative number. So situations where it would work would be like x plus 3, x minus 3, x plus 7, x minus 12. Where it does not work, these all will check out for synthetic division. But if I had 2x minus 1, it will not work. If I had 3x plus 7, it does not work. It only works when the leading coefficient here is a 1. So what you do with synthetic division is you take what you're dividing by and you solve it. Y minus 2 equals 0 gives me y equals 2. So we're going to put a 2 on the outside, and we're going to set up our situation here. So here you take you take this first part, which is a cube, a squared, a first power, and a constant. There's no missing terms, so there's no placeholders. So you take the coefficient of each degree term and you write it out. Here we have a 1. Put a space. We have a 5. Put a space. We have a negative 7. Put a space. We have a 2. Whatever number is left over here becomes our remainder. So once you have set this up, we go ahead and start our process. Take this 1, bring it down. Now we multiply when we're on the outside, we combine when we're on the inside. 1 times 2 is 2. Combine. That gives me 7. 7 times 2, 14. Combine. And that gets me 7 again. 7 times 2, 14. Then we combine and we get 16. So right here, how do I write my final answer? Well, this is the remainder. This would be our constant term, or x to the 0 power. This would be x to the first power, and this would be x to the second power, and so on if I had more numbers. So to write this out, I want to write it in remainder theorem form. So I've got 1x squared plus 7x plus 7, and then you put a plus sign. You have 16 over what you divided by, which was y minus 2. That takes care of division with long division and synthetic division of polynomials.